Okay, I think we managed to introduce everybody. Basically the reason why we call this meeting is because in the last, I've been getting quite a bit of questions about IWFM and IDC, different versions, what they do, and if it is easy to use one version compared to another, and we're happy to answer the questions. We found out that we've been answering the same questions, varieties, for individuals over and over again. So we decided to hold this meeting so that we can answer all the questions that we have gotten so far for everybody interested. Also, answer new questions if you have any new questions. So please, interrupt me. I can't see your faces. I don't know if you're bored or sleeping. So if you have any questions, just don't hesitate to interrupt me and ask your question. That way I'll know that, you're there still able to follow the presentation. Okay. So I'm going to start with a quick background on IWFM and IDC. And how we came about with the different versions of these models. So when you first come into this IWFM world, first thing you notice is these different versions. Right now we have IWFM version 3.02, version 4.0, and then to complicate the matters, we have what we call IDC, IWFM Demand Calculator, version 4 as well. So what are these different versions and what they mean? And just to give you, again, a quick background, our own application of IWFM to the Central Valley of California uses IWFM version 3.02. C2VSIM stands for California Central Valley Groundwater Surface Water Simulation Model. And, we are using version 3.02. So this whole versioning system came around when I think it was year 2005 or 2006, when we started development of CalSIM 3. CalSIM is a systems operation model. It uses techniques from operation research analysis, and we use this model to simulate the reservoir operations in Sacramento Valley and San Joaquin Valley. And one requirement of this project was to link certain components of C2VSIM, namely the root zone component and the groundwater component, into CalSIM 3. So at the time, what I did was I went into IWFM version 3.02 with a surgical knife and carefully cut out these components, the root zone and groundwater component, to be able to link to CalSIM. But very quickly we realized that that's a very error-prone approach. It's not easy to maintain that approach. For instance, if you find a bug in IWFM engine, you need to correct that, and you also have to go in and correct these individual components. So it wasn't an easy approach. So that was very quickly that became apparent. So we realized that we need to redesign the IWFM engine as well as its components, so that we can take these components just like Lego pieces, easily plug and unplug into IWFM or other models like CalSIM. And during the same project, we also realized that the root zone component needs some improvements, needed some new features, and I'm going to talk about those new features, what we included. So ultimately, what came out of this new approach was this newly designed root zone component, what we called IDC, IWFM Demand Calculator. So this root zone component is a standalone component, which means that you can actually run it by itself without having to link it to IWFM, but it also easily links to IWFM. So at the time, this root zone component was an important aspect of the project. That's why we started developing this standalone component. But now that we had this IDC version 4.0, we needed to link it to IWFM, but version 3.02 of IWFM wasn't designed to accept this plug-and-play type component. So we ended up modifying the IWFM engine as well. We ended up with IWFM version 4.0. So if you look at these two versions of IWFM...
excuse me, John. John, this is Tarek. Sorry for interrupting, but just for clarification, Calcium 3 has not been released to the public yet, just in case anybody has any questions.
Okay, so if you look at these two components, these two IWFM versions, schematically, what you'll see is that version 3.02 have these individual hydrologic simulation components, but they're kind of tightly into each other. It's not easy to take out one component and replace it with another version of that same component. As IWFM version 4, we basically took out the root zone component and called it IDC version 4.0, and now it's easily linkable to the rest of the components. At the same time, you can use it as a standalone model. So basically, when IDC is linked to the rest of the components, well, first of all, what IDC does is it computes in the root zone based on the soil parameters, crop distribution, atmospheric conditions, and whatnot. It computes the water demands for our cultural crops, and it also routes the water through the root zone and land surface system. It calculates deep percolation, vertical outflow from the root zone. It calculates rainfall runoff and changes in the root storage in the root zone and so on and so forth. So when you link the IDC to the rest of IWFM, it has a knowledge about groundwater and streams and the rest of the system. So the deep percolation, the vertical outflow from the root zone, comes recharged to the groundwater. Surface runoff comes inflow into the streams. It calculates demand, so you can actually meet that demand from groundwater pumping or stream diversion. And since the system knows about the availability of the water in the system, groundwater and streams, it's likely that if you have too much demand, maybe you won't be able to meet that demand if you don't have enough water in the system. So when IDC is linked to IWFM, if you use it as a standalone component, then it has no information about the groundwater or streams or anything else. It still calculates the demand. It still calculates deep percolation and surface runoff. But in terms of meeting the demand, that the water is just there. Demand is met perfectly at all times, again, if you're using IDC on its own. Deep percolation and surface runoff essentially leaves the control volume and gets lost to the system of the root zone.
John, I have a question. This is Ali. As you're explaining the IDC version 4.0, I remember that there was an IDC version prior to the 4.0, which was also simulating the same conditions, land surface processes and root zone, except it was geared based on the IWFM version 3.02 concept. This is something that we used a couple, 3 years ago in a couple of the projects that we had. So can you shed some light on the differences in terms of the root zone accounting for the IDC that you have in here in yellow versus the IDC that is out of the IWFM version 3.02?
I will do that in the next few slides, when I talk about the differences between the two versions.
Oh, okay.
Yeah, I mean, that particular version we are using for calcium. It's still being used for calcium, but we have not necessarily publicly released, on our website, like we did with IDC version 4.0. But I'll talk about the differences.
Thank you.
Let's move on. Well, okay. So the differences between the two versions. So basically, if you go back in version 3.02 and version 4, all the components are pretty much the same except the root zone component. So the question, what is the difference between version IWFM version 3.02 and version 4.0, is really boils down to the question, well, what are the differences between the two root zone components, basically? That's what I will be explaining, the differences between the two root zone components. So the first one, which is very important difference, is that in version 3.02, the agricultural crop properties get averaged for an individual subregion. Let me explain what a subregion is. Probably most of you know, but in IWFM or in IDC, you group individual grid cells into subregions. And these subregions generally, in the past, are based on how the water is used, model area. Like, for instance, water districts generally represent individual subregions in the model area. So essentially, you group the elements into subregions. And however you want to do that in a particular application is up to the user. So the agricultural crops, again, are averaged, the properties are averaged for version 3.02. The rooting depth, soil moisture requirement, irrigation efficiency, potential ET, so on and so forth. So at the end of the day, even though you enter parameters for individual crops, internally IWFM 3.02 ends up with a representative single agricultural crop. Which means that some of the detail is kind of lost in that case. There is no averaging version 4.0, which means that each crop, agricultural crop, is treated separately, and the simulations for those crops are done separately. So this is an important difference between the two that probably leads to some differences in the results. Second important difference is that in version 3.02, land surface and root zone flows are computed for each subregion for each soil type. So basically, for each subregion, we have 4 land use types. We have that averaged representative agricultural area, and we have urban, native vegetation, and riparian vegetation areas. We have a total of 4 land use types that we simulate in version 3.02. On top of it, we have 4 soil types. These are A, B, C, D. Basically, if you remember SCS curve number method, are the hydrologic soil groups. Essentially, version 3.02 calculates for each subregion, calculates the root zone flow terms for a combination of 16 locations, I guess. 4 land use types and 4 soil types. What it does is it creates a lookup table. This is a dynamic lookup table at each time step for these 16 possibilities. And these are the flow terms are computed in terms of unit rates. And each element is basically given a proper soil type, A, B, C, or D. And we know, these are input parameters, we know what the areas are, element of the land use types. So for instance, you're looking at one time step, you're looking at element 5, agricultural area, you know that element is soil type B. So you go to your lookup table, you look up, okay, what is the, let's say, rainfall runoff for soil type B agricultural area. You get that, unit rate, let's say 3 inches per month, multiply it with the acreage on that element, and you get the volumetric rate. So that's how version 3.02 calculates. Again, basically the idea is that in version 3.02, the calculations are done at a sub-regional level. Version 4.0, the calculations are done for each element, for each agricultural crop, and also for urban lands, native vegetation, and riparian vegetation. So again, there's no averaging, and version 4.0 honors the spatial distribution of the land use. And it doesn't have the restriction of having 4 soil types. For each element, you specify soil properties, so potentially you can have as many soil types in your model area as the number of elements in your grid. So just to give you an example from C2V-Sim, in C2V-Sim we have basically 14 agricultural crops, but they all get averaged in version 3.02. So you end up with a single agricultural crop, and then then basically 4 land use types and 4 soil types. So we have basically 16 times we have 21 subregions. 21 times 16 is apparently 336. So we do 336 root zone moisture accounting in C2V-Sim when we use version 3.02. But if you run C2V-Sim with version 4.0, then we have 17 different land use types. Again, 14 agricultural crops and 3 other land use types times about 1,400 elements. We end up with 23,600 root zone moisture accounting. So basically what this tells you is that version 4.0 more computation intensive compared to version 3.02. There's no free lunch. You get a little bit more detailed information in version 4.0, but it takes longer time to execute your program. In version 3.02, we don't have a special way of simulating the ponding operations and draining operations of rice fields and managed wetlands. Whereas in version 4.0, we do simulate operation of rice fields. We actually have 3 types of different rice based on how they're decomposed. These are flooded decomposition, non-flooded decomposition, decomposition, and we simulate 2 different types of managed wetlands, seasonal or permanent. Now, regarding this rice, why we have these 3 different types? Again, in California, for instance, until 1990s, the rice paddies were burnt. So that was the decomposition, where basically they didn't decompose them, they just burned. But after, I think, 1995, burning was banned, and since then, farmers have been using water, diverting water to do either flooded decomposition or non-flooded decomposition. So if your model simulation period, let's say, goes from 1970 to 2006, let's say, your rice water demand will be different, particularly in the decomposition period, which is generally from September to December, I believe. Your water demand will be different before 1995 compared to after 1995. So the idea is to be able to represent the historical rice growing operations properly. Going to the next item, in version 3.02, you can either have IWFM or IDC, root zone component compute the water demands dynamically, or you can prescribe the demand as an input, and IWFM will basically just skip the dynamic calculations and use the input, the prescribed demand. But you can't mix and match the 2 of them, the 2 options in a single relation. Whereas in version 4.0, you can actually mix these two options. Now, why is it important? Again, if you think about Central Valley, we have CVP, SWT, California Central Valley Project, State Water Project, and water users, who have access to the project water, divert water, and that diversion is actually historically recorded, have access to that. So in a historical run, for instance, you might say, okay, I have the diversion records, so I'm going to assume that I know what the demand is. Demand is, let's say, equal to the diversion, so you can prescribe the demand for those water districts. But in other water districts where they don't have any access to project water, they generally groundwater pumping. In California, we don't have pumping recorded or measured. So as a modeler, you don't have any access to the historical pumping records. So what you can say now, okay, I'm going to let IWFM calculate the demand for these water districts that rely on groundwater. Let IWFM, meet the demand with the supply. So in version 4.0, you can actually have part of your model area demand dynamically computed, and the rest of the model area you can basically prescribe if you have to do that. Okay, the next item is now since in version 3.02 the demand calculations are done at the subregional level, the resolution between water demand and water supply is also done at the subregional level. Whereas in version 4.0, since now our calculations are at an element level, you can actually have water supplies. Water supplies go to specific elements, and target specific elements if you have that kind of information. Or you can still let IW 4.0 deliver water to a subregion. So it all depends on how much. And finally, since the root zone component is tightly linked in version 3.02, you have to calibrate the model during the calibration process. You have to calibrate the model as a whole. Whereas with version 4.0 of IWFM, you have the option to calibrate the model as a whole, or you can actually take out the root zone component, the IDC version 4.0, and calibrate that first, and bring it back into IWFM, and then calibrate the rest of the model. It basically, we did this, actually not us, but the consultants who were working on the project did this for Yolo County model. The consultants had a really good idea about the water demands, the general numbers for the flow terms, deep percolation, rainfall runoff, so on and so forth. So they were able to calibrate the root zone component, the IDC, and bring it back to the overall model. So it basically helps in terms of run times. Again, just to give you an idea, for Yolo County model, the IDC part took only, I think, 15 minutes to run, whereas the whole model took about 2 hours to run. So that kind of gives you an idea if you have to calibrate the whole model as a whole, kind of run times you'll have to deal with. What are the advantages and disadvantages of using either IWFM version 3.02 or version 4? Well, as I said, version 4.0 allows you to simulate the system with a finer detail, but this comes with a price. You need more parameters to represent the system. And specifically, you need a better understanding of how the root zone component is working, particularly in the real world. In version 3.02, the averaging actually makes IWFM 3.02 little bit more forgiving, averaging of the crop property. So actually have some mistakes in your input data or inconsistencies, but because of the averaging, those mistakes kind of smeared around, and they don't necessarily always come out in the results with a disastrous effect. Whereas in version 4.0, now that we are simulating every crop separately, consistencies, if you have any issues with your input data, they actually show up generally in your results. So it really is important when you use version 4.0 to understand like how the farmers are managing their crops. When does the irrigation period start for a crop? When does it end? So on and so forth. Again, version 4, because it addresses finer detail, it also takes longer to run compared to version 3.02. But as I explained, particularly in the calibration phase, you can a little bit remedy that by calibrating the root zone component first and then bring it into the entire model, calibrate the whole model. Version 4 does a better job in simulating the effects of rice fields and manage wetlands and water resources. Version 3.02 doesn't have that. And version 4.0 honors the spatial distribution of precipitation, ET, crop water demand, and the resulting stresses on groundwater better. So I can give you two examples for this. One of them, let's assume that in a single subregion of your model, precipitation varies drastically from one part of the subregion to the next. In version 3.02, since that there's an averaging going on and everything is done at a subregional level, use this variability in precipitation. Whereas in version 4, since all the calculations are done at an element level, actually retain that spatial variability in precipitation. Another example is, again, you look at your subregion, and let's say half of the subregion you're growing rice, the other half of the subregion, let's say you're growing grain, dry farmed grain. So in version 3.02, crops will be averaged, and you will have a single representative crop, and when the demand is calculated, that water demand will be actually for the entire subregion, not for rice area, not for grain area, but for the entire subregion. So most likely what will happen is you will be underestimating water demand for the rice area and overestimating the water demand for the dry farmed grain area. Whereas in version 4.0, you will be able to represent this spatial variability in the demand, because you will be able to simulate rice separately than the dry farmed grain. So, okay, these are the advantages and disadvantages, but then, okay, what is the choice? How do you make a choice between the two versions? And basically, this is true for, I think, any modeling project that uses IWFM or any other model. It's basically, it depends on the characteristics of your modeled area, the project requirements, and the budget of the project. So, for instance, you might have a small area with minimum spatial variability in your precipitation and the crop distribution and whatnot. In that case, version 3.02 will be and easy to calibrate compared to version 4.0. Or you might have a highly variable system, but the questions that you're trying to answer in your project might not require those models. In that case, again, version 3.02 is adequate compared to version 4.0. And of course, budget is an important restriction also. But one thing that I want to point out here is that even though version 4.0 of IWFM is our latest version That doesn't mean that we are stopping support for version 3.02. For one thing, our own model, C2vSim, still runs on version 3.02, and it took us at least a decade to calibrate the model. So C2vSim with version 3.02 is not going anywhere. We are planning to migrate it to version 4.0, but that's not going to happen overnight. Probably we are going to spend another decade or so to do that. So if you're interested in trying to figure out which version to use, version 3.02 or version 4.0, don't make the mistake to think that we're no longer supporting version 3.02. That said, one thing that might play an important role in your decision if you want to choose 3.02 versus 4.0 is what is coming next, what kind of new features we are going to be introducing IWFM. At this point, we are not planning any major development for version 3.02. All the new features are being built on top of version 4.0. So one of the features that we have actually implemented and using it right now internally and kind of testing internally is this root water uptake from groundwater. So we call it IDC version 4.1. And basically, this feature is important if you're, simulating mainly native and riparian vegetation. Generally, this is not an issue in farmlands, since farmers try to control the groundwater elevation, but it becomes an important issue, in native and riparian vegetation areas. Another feature that we actually started looking into is the hydrologic routing of streams. Currently, we do not keep track of the storage change in the streams, meaning to release a certain amount of water at the upstream of the model, that water will show up. I mean, we calculate the ins and outs through the system, but that water will show up at the downstream of the model within one time step, regardless of what your time step is. With this new approach, hydrologic routing of streams, we will be able to keep track of the storage change, meaning if that particular water that's released upstream doesn't have enough time to reach downstream, we'll be able to track that. I will be preparing a summary sheet and frequently asked questions, kind of put all this into a kind of a white paper type of document. And I would like to put together a summary sheet on different versions of IWFM and IDC and the upcoming components as they become available, so that people hopefully can look at and figure out, okay, what does one component, version of component do versus another version, and what parameters are required, and so on and so forth. And as I said, these new features are implemented mainly on top of version 4.0. So currently, if you have a version 4.0 model, I think you will be able to migrate them to new future versions easily compared to version 3.02. Although we have an idea of how to make version 4.0 backward compatible. And at the end, what we would like to see is that all components will be able to run both as a standalone program or as part of IWFM, so that we can take these components and link them to other models as well. That has been our major issue in DWR, trying to link these to other big models.
Hey, John, this is Abdul. I have a question
on
these two versions, especially this bullet, new features are implemented and not planned for. Say, for example, if a modeler, for whatever reason, wants to basically use the model version FM version 4.0, but he wants to or she wants to default into version 3.02. Is there any feature in version 4.0 which sort of then, because of whatever reason, data availability, funding issue and so on, basically sort of like version 4.0 then defaults into the mechanism of version 3.02?
Yeah, not currently, but that's something that we would like to build in, again, for backward compatibility. Actually, this was suggested by Ali Tagavi from RMC Rhyme, which is, I think, a great idea. And basically, in the future, I think this is how the schematic of IWFM will look like now. The hope is that in the future, rather than talking about individual versions of IWFM, hopefully we will be talking about a certain application that uses specific versions of individual components. So basically the idea here is that now we have IDC in the root zone package 4.0 and 4.1. The idea is that take out the root zone component from version 3.02 and then basically put it right here so that IWFM can access to that feature as well as a measure of backward compatibility. So that's the idea.
I was looking at from a very different perspective, though. Not, necessarily use version 3.02, but basically just, in future you say you want to abandon that. But in version 4.0, you have some sort of triggers which sort of then mimics, a simplified version based on data availability and cost, budget for the project. Because then, otherwise what will happen is you'll continue to maintain these multiple versions rather than having a refined or more sophisticated version which has in it a built-in feature to mimic a more simplified representation of the system.
My experience is that the data and the method of calculation are very linked to each other. If you say I'm going to use this method, then you have to come up with certain parameters for that. So if you want to use version 3.02 parameters, but with a sophisticated approach, you may not be able to do that. For instance, version 3.02 does not have the proper parameters for rice, right? It has nothing to do, it has no information about ponding depths and whatnot. So you cannot say, well, I'm going to use whatever data available in version 3.02, but I want to be able to simulate rice ponding. You just can't do that. So I think what we will have to do to address that is just find the right combination of the data and the computation approach, and then come up with different versions. I don't know how else to do that. For instance, ModFlow is pretty much the same way too, in my opinion. They have all these components, like river package, SFR1, SFR2, and so on and so forth. And I think it's the same idea with model.
Okay.
So I would like to talk about the available preprocessors and post-processors, which are all from our website. If you go to IWFM website and follow the link to support tools website, which are all downloadable for free. I would like to talk about these tools. The first one is the IWFM GIS graphical user interface. This one works only with version 3.02 at this point. And when you install it, it comes out as a little button, as an extension to ArcMap environment. And it's a very simple GUI. You can't really build a model from scratch with this GUI. That's where we want to go eventually, as we have time and money. But right now what it does is it basically reads the IWFM input files, particularly the preprocessor files, and creates these shape files for grid, the subregions, the stream nodes and streams and all that. And you can look at the initial conditions, the stratigraphy information. But at this point, that's all it does. We have another tool called IWFM Mesh Generator. Again, when you install it, it will come out in ArcMap environment as a button. And this is, I think, a pretty promising tool. What it does, it basically brings the mesh generation process, which you need when you start a project from scratch in finite element approach. It brings the mesh generation software into ArcGIS because mesh generation process is an iterative process. It's not okay, I'll click a single button and I'll end up with a mesh that I'm happy with. It doesn't happen in the first trial. What you do is you basically develop your shape files in GIS that are going to drive your mesh generation process. Then you bring it in your mesh generation software, whatever you're using, hit your mesh. Most likely you'll have some issues with the mesh that was created, which probably will lead you to some other modifications to your shapefile. So it's a process, generally an iterative process between your GIS and your mesh generation software. In this tool, brought the two together, so you're completely in the GIS, and you can do all sorts of analysis and everything. You have the whole power of GIS under you. And you can do basically this iterative approach right here. You can go back and forth by clicking between different meshes that you've created between these arrows. But still, this tool is in a development process. Right now it can only generate triangular meshes. We would like to also incorporate quadrilateral meshes to that. We just couldn't find anybody at this point who will be writing us a software for the quadrilateral mesh generation. But it's, I think, a very promising tool. Another one is the IWFM tools add-in for Excel 2007 and 2010. And again, when you install it, this comes up as a new tab, IWFM Tools tab in your Excel, and there are several tools here, and we are using it as a framework. As we come up with ideas, either as preprocessors or post-processors, we are planning to build those into this tool. One of them is basically, you can export space delimited text from Excel text file. The problem is, why we needed this is, again, IWFM or IDC uses columnar text data, let's say time series data. And we generally create those data in Excel. And the problem is when you export from Excel text file, if you have more than 256 columns or something like that, the lines start wrapping up. So to avoid that, we developed this so that you can have as many columns of data exported as you want. Another one which I find myself very useful is you can actually create a water year month table from any time series data. What you do is you select your time column, whatever your time series data you're dealing with, and it will create you a table. On the rows you will have water years, and on the columns you will have months. And if you have, for instance, your time series data in a daily interval or 1 minute interval or whatever, it will actually aggregate these values to months automatically. And you can also do unit conversions. If your data, for instance, is in CFS, your output table can be in million acre feet or 1,000 acre feet. So I find this very useful as a post-processor. Third tool here is the budget to Excel tool. IWFM or IDC creates these binary files which for water budget information for different components, for groundwater, on whatnot. They're in binary format, and you can use this tool to automatically get that information into Excel for their analysis. And when you click that, this is that comes up. You choose your binary file, you choose your conversion. You can actually convert your data, let's say from square feet to acre feet, or acres or whatever. You can do aggregation on the fly. If your simulation is daily, you can ask for the data to be exported to Excel monthly or annual or whatever. I find this very useful. Another one is the Soil Data Builder. This also comes in handy when you're using IDC version 4.0. Basically, IDC 4.0 requires several soil properties: hydraulic conductivity, pore size distribution index, total porosity, fill capacity, wilting point, so on and so forth. And that information is actually available in NRCS Surgo soil database. But I don't know if you ever work with those databases. I find them very cumbersome. There's a lot of tables in there. There's a lot of data, a lot of relational stuff. About 98% of the database is not necessary for our purposes. So, when I first developed IDC version 4.0, I found myself manually constantly doing like a whole bunch of averaging and, bad data weeding and whatnot from these Surgo databases. So I ended up developing this tool that will basically automate that process. It basically accesses a Surgo database. In this case, it's accessing Glenn County's soils, and then we'll do all the processing of the data and print out text files for the parameters that IDC needs. And then you can basically bring those text files directly into GIS, your analysis, intersect them with a model grid, and basically get your soil properties for each element. The other one is land use adjustment preprocessor. One thing that people always are concerned, especially if they are interested in using IWFM version 4.0, is it requires crop formation for each element for every year of your simulation period. Well, that information is not available, so how do we get that information? What this does is it basically, at least in California, I don't know how it is in other states. In California, we have, for each year, Ag Commissioner's reports. These reports list the total crop acreage for each county. So you know the acreage, but you don't know the physical location of these crops. The second database that's available is from our Department of Water Resources. We have land surveys. These are essentially snapshots in time for you maps of where these crops are, but they're not, given for every year. So let's say for Yolo County between 1970 and 2000, you have two snapshots. You have one snapshot for 1997 and one for 1989. So what this tool does is it takes these two databases, the snapshot in time that shows where the crops are and the total crop acreages in each county, and basically interpolates, extrapolates, creates land use information, land use acreage for each element. That's one possibility to get that information. And finally, we have a tool, what we call ArcGIS GUI for C2V Sim. This is currently geared specifically for C2V Sim, but we have gotten several questions. Actually, quite a bit of users are interested in using this, but they are curious if they can use this tool not for C2V Sim, but for their own application. So what this tool does is basically, when you again install it, it comes up again as a button in ArcMap. and you basically connect to a database, a geodatabase, where we have already imported all the C2VSIM results into, and this GUI actually connects to that database. So what you can do is, for instance, you can click on a subregion. It will show you all the information that's available for that subregion. Some of the input data, all of the output results data, and you can choose one of them and start, charting them or making, time series analysis on the. So again, as I said, currently this is only geared towards C2VSIM, but we are planning to make this tool generic so that anybody can actually import their model data into the geodatabase and start using these visualizations. So that concludes my presentation. Hopefully I didn't bore you. Hopefully you were able to follow the presentation. Any questions at this point?
Yes, John, this is Abdul. You showed in the Excel a budget tool, and then the final, the GUI for the C2VSIM. I'm just curious, is there in any of these tools an easy way to sort of define subregions which are not in the original, implementation of the model, define a subregion, and then quickly get a budget for that newly defined subregion?
Yeah, so that doesn't exist tools yet. We have something called Z-Budget or groundwater. So what you can do with that tool is, you can run that. You can identify, individual elements and redefine new subregions, and that will give you water budgets for those newly defined subregions. But currently, it is only runs and creates text files. But my plan is to actually modify it so that it can be actually done within Excel, and I'm sure we can also link that to the ArcGIS GUI as well.
Yeah, because if you can, for example, just as a suggestion, in the ArcGIS GUI, if there is an ability for a user to basically mark up a zone, and then that zone becomes, for example, a newly defined subregion, and then the user does not have to worry about what are the element numbers and so on. So I'm just looking into the future, because some of the things, and then McManus, he can also probably, jump in, is if we want to look at a budget for a groundwater basin or sub-basin, we really need that ability to quickly define or sort of create that boundary and then generate that information. I think that would be actually a really, really useful tool for us to use in the future.
Yeah, for us too. Actually, the same question was asked by my colleague. He was wondering if you can do that with the Z-Budget. So that's high up in my.
Okay, great.
And of course, the next step, you first do the source code writing, but then the next step is to set up the visual tools, right, that will allow you to select the elements within the GIS and get the information. Yeah, I mean, that would be a great tool.